Hey guys, this is Alan with Bothell STEM Coach, and today we are looking at some more kinematics questions for AP Physics. Now, I kind of ran out of questions to do for kinematics, but I figured a good way we could continue doing kinematic problems is just maybe not necessarily look at just AP questions, but look at a variety of different kinds of. So I've pulled in several kinematics questions just from different college classes, different other classes that are similar to AP Physics 1. Some of the questions might be a little bit harder, but overall I think this will be a good approach to look at some more kinematic problems. This one might be an old AP exam question, so I don't recall where I grabbed this one, but let's read it. Now, because some of you guys might not have seen these before, what I really suggest is you pause the video, take a look at the question, see if you can do it, try it out, and then look at the rest of the video just to see if you got the same answer as I did. So a 0.2 kilogram object moves along a straight line. The net force acting on the object varies with the object's displacement as shown in the graph above. The object starts from displacement x equals 0 at time t equals 0 and is displaced a distance of 20 meters. Determine each of the following. The acceleration of the particle when its displacement x is 6 meters. So at 6 meters, this graph tells me his force is 4 newtons. Okay, let me shrink that a little bit. That's a little bigger than I wanted. Okay. Now, we know that F equals ma, so it's not quite a kinematic question, but hopefully you do know that F equals ma. And so the acceleration is just equal to F over m. And since I know the force is 4 newtons and I know the mass is 0.2 kilograms, I know the acceleration would be, what is that, 20 meters per second squared. Okay. The time taken for the object to displace the first 12 meters. Well, so this whole time he's subject to a constant acceleration of 20 meters per second squared. If I want to look at displacement, I'm looking at this kinematic equation, v naught t plus 1/2 at squared, or I'm looking at this equation, v squared equals v naught squared plus 2a delta x. Both of these are fine equations to solve for delta x, which is the displacement. So I'm trying to figure out what I have here. The initial velocity. I know that the initial velocity is 0, given that it started from rest. Okay. I know the acceleration. I don't actually know its time, so that one's a little bit tricky here. Oh, actually, I'm solving for time. I know the displacement. Okay, so this is the equation I want to use. So I don't really want to use this one because I need to solve for time. So delta x is equal to 1/2 at squared. So solving for t, I get it's 2 delta x over a, take the square root, right? I brought the 2 over, divided by a, and then I took the square root of this. So this is the square root of 2 times, what was the displacement? 12 meters, divided by 20 meters per second squared. That's square root of 24 over 20. 24 over 20 divided by 4 at 6 over 5. We'll say square root of 6/5. I don't have my calculator, so I'm not going to deal with that. The amount of work done by the net force. Okay, let's skip over the work done problem just because, well, you know, the problem with the AP questions is they're more than just category by kinematics. This is a work done problem. Work done's force times distance. So this is actually a pretty easy one. It's a constant force over 12 meters. So that's 4 newtons times 12 meters, and that's 48 joules. Okay, so that's okay. If you guys haven't gotten, wherever you're at, if you haven't gotten to work being done, that's fine. You don't worry about that. The speed of the object at displacement x equals 12 meters. Okay. So I want to know his final velocity, given I know this equation, but his initial velocity was 0. His acceleration was 20 meters per second squared, and the time for the 12 meters we solved here in part B, it's the square root of 6 over 5. I'll go ahead and grab my calculator just to give some specific numbers, but I mean I'm fine running it as 20 root 6 over 5, but maybe if you want an exact answer, we would get this is equal to 21.91 meters per second. Okay. The final speed of the object at displacement x equals 20 meters. Okay, so this is a little bit of a trickier one, right? Because the force is declining over here. That means his acceleration is changing. Now, in general in AP Physics, you're not necessarily expected to know what happens under non-constant acceleration scenarios, but in this way, if you were to use it under principles of principles that you would know in AP Physics 1s, you know that the area under this curve is the work done, okay? And so the work done goes into the kinetic energy. So I'd say 1/2 mv squared equals the work done, work energy theorem. We found this work was 48 joules, like this area here. This area is 8 times 4 divided by 2, so that's 16 joules. So there's a total of 64 joules. And I can solve for V now. So V squared is equal to 128 joules over m. So V would be the square root of 128 over 0.2. 28 divided by 0.2, square root of that. I guess this is 25.3 meters per second. Okay. So you're not required at this point for this kind of this part of the problem. You wouldn't necessarily use kinematics to solve this equation, although you could. Just you would have to use integral, some calculus to use kinematics to solve it. So that's why energy is probably a better way to look at it. The change in momentum of the object is displaced from 12 meters to 20 meters. Well, his speed changed from here to here. So the change in momentum is m delta v, because mv is momentum. The only thing that can change is the velocity. The mass doesn't change in this problem, and typically doesn't change. Actually does change in some scenarios. I wonder if you guys would think about what scenario would a mass. A very not common example is a rocket launch, because the rocket gets lighter as it burns fuel. And so the change in momentum is 0.678, and the units of momentum are kilogram meter per second. Okay. So hope you guys found that helpful. We'll continue on more dynamics questions in the next, not dynamics, kinematics questions. I'll see you guys in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.